Welcome everyone to the data visualization by Dan Hilary. I am Wedad Anbtawi, the organizer of this workshops on behalf of FruitPunch AI and ADTECH. And Dan?
Hi, so my name is Dan Hilary. I'm a data scientist. I work in ADTECH, so advertising technology, for a company called Integral Ad Science. One of the things I do most days in work is some form of data visualization. And I work pretty closely with our marketing team too, and to help them visualize our data. I guess we'll get into it. And like Wedad said in the chats, if you'd like to tell us a little bit about yourselves, about your backgrounds, your uses for visualizations, that'd be great to hear about. Just type in. So today, we're going to look at a couple of different things. But we're mainly going to just look at a whole bunch of different visualizations. And we're going to try and critique them, try and look at them and see how could it be better, what's not quite right about them, what is right about them. And the overall goal, I guess, is to hope that you can see that there's a certain art to figuring out what a good visualization looks like. There's a way of looking at visualizations and saying, well, if this were simpler, if this were clearer, there's a lot of kind of aesthetic choices to be made. But also there's a lot of ways in which a data visualization can mislead and can obscure whatever story you're trying to tell in your data. In that theme, usually when I look at a data visualization, I try and think of 4 different aspects of it, look at 4 different questions. The first one is whether the visualization is correct. Correct in the sense that it accurately reflects the data and is, it accurately kind of reflects the data and it doesn't mislead the person who's looking at the visualization. And there's all sorts of ways that we'll see that can happen. So correct in the sense of like, is this a fair representation? Is it scientific? The next thing is, usually when you look at a visualization, you will have questions about the data that kind of spring naturally from it. And a good visualization should answer those questions, right? And we're going to see lots of that too. Another thing is, if you want your visualization to be intuitive, right? And a person shouldn't have to kind of guess what different things on your plot mean. They shouldn't have to kind of know a whole lot of statistics or read a lot to try and figure out what's going on. It should be pretty obvious insofar as it's possible. And the last thing is it just ugly? I mean, these things need to be appealing for 2 main reasons. If a plot is ugly, people just won't be interested in looking at it, but also it reflects kind of poorly on the person who made the plot, and it kind of weakens your ability to tell the story that you want to tell with data, because the person will kind of almost not trust you. They won't think that it's kind of a professional source, or they'll think that if the plot is kind of haphazard, then the data must be too. Okay, so here's a plot that I saw last week on Twitter, which I found kind of funny but revealing. So this is something that was going around, and I think it's super interesting, and I'd love if you guys would post in and tell me what you think of this plot. What's good, what's bad, any thoughts you might have. I'm going to give you a minute to do that, maybe. Don't be shy. Yeah. Okay, so Zayed has suggested that maybe one of the problems with this plot is, you have these big figures, and we could have just used a bar chart, and probably would have been clearer. That's definitely something that's kind of questioned about this plot. It's always good to remember with any of this, it's very subjective, and so very often I find that I might like a plot I made last week and dislike it the following week, and that's totally fine. But here it seems a little bit difficult. I mean, if you look at the way they overlap because they're figures, it's just hard to see what's going on. The biggest problem I think I see with this plot is that the y-axis doesn't start at 0 here. It starts at 4.5 or something. And so the reader kind of gets the impression that a Latvian woman is 5 times taller than an Indian woman, when really it's about 5 inches in the difference on average. So in that sense, this plot is not correct. And I guess, and that's what the person who put out this tweet is trying to say. It really misleads the audience badly. And you could say, sure, in a technical sense, well, all they had to do was read the scale. It's there. It's not wrong in the sense of the numbers are wrong. But I still think it's wrong in the sense that any reasonable person looking at this plot would be left with the wrong impression. And yeah, I don't think it's necessarily ugly, but yeah, and also, so Syed has brought up this idea of color. It's true that one of the issues with the color here is that we're talking about countries, and they have separate the countries are just separate categorical things with no particular pattern. And yet, by using all the same hues, you kind of suggest there should be some kind of pattern there. And I think it's something we're going to talk about a little bit more in a minute. So yeah, so that's good to talk about. Let's look at a few more. We're going to move on to a specific kind of example we're going to build up. Okay. So let's see. So this is a little kind of case study almost that we're going to use for the rest of the hour. And in this case study, I have a data set. It's called the Gapminder data set. It's pretty well known. And it has life expectancies for different countries all around the world for the last 50 years in it. I've taken a slice of this where I just look at the average life expectancy in different continents for the year 2007, right? And I found this plot online, which I thought was interesting. This person made this plot based on this data. So this is definitely one way to do it. But you can, if you look closely, you can see there's a lot of problems with this plot, right? The first thing that I think is a big problem is that when I look at this plot, I actually can't tell you reasonably well, what life expectancy is in, say, the Americas, right? Because the way that the axis is and this weird shadow and 3D effect has obscured all of that, okay? So I mainly should, there's a couple of things that I just don't like about this plot, but the biggest thing is that the 3D effect really hides the data. And it means that if you try and ask a question about the data, you might run into trouble. So for instance, here, a normal question to ask would be well, who has higher life expectancy? Is it Europe or the Americas? All right? And to me, it's not entirely clear from this plot what the answer is. Similarly, if you were to ask yourself what the life expectancy in Asia was on average, you'd probably say 67.5, and you follow down that line, which turns out not to be the case, okay? So, how do we fix it? Okay, well, we could do something like this, all right? We could reduce, we could reduce visual noise, as they call it. There's a concept in data visualization called the data to ink ratio. And the idea here is that the things in your plot, you want to maximize the amount of things that actually show the data and minimize other frills. It's kind of a general thing. Some people take this too extreme. If you look at this chart, I think it is too extreme. So it has some advantages over the last one, which is that for one thing, you can actually tell much more clearly what the actual values are. So if you want to know what the average life expectancy is in Asia, it looks pretty clear to be 69-ish, which is the correct value, even though the other chart would have maybe told you something less. So that is one thing. Feel free to post in ways we can improve this chart. I'm going to show you a few of my ideas for how we could do this. So the first thing I thought was worth doing is adding color, right? Adding color here is not necessary in the data sense, in that there's no particular reason why you're trying to split up different, you're not representing anything new in the colors, but it really helps visually. The other thing that helps visually is, when you have a bar chart like this, you should probably try and pick some kind of sensible ordering. Before it was just ordered in alphabetical order of the continents, which is totally meaningless. Here I've chosen to order it by the values, which helps because then it makes it very easy to say, okay, Oceania has the highest life expectancy, followed by Europe, followed by Americas, and Africa is quite a chunk lower. Okay, but there's still even more improvements you can make here, right? So for instance, the legend here doesn't really serve any purpose, so we can get rid of that. And the labels also, right? The labels are pretty meaningless. So we have life exp, which is not helpful for a general audience. And we have this thing down here, which is a kind of a relic of how I coded it. And again, it's nonsense. So we need to fix those. So we could do something like this. Here, you can actually see that I've gotten rid of the labels altogether. Why? Well, there's no particular reason we need them. I mean, it's very clear that the names at the bottom here are continents, and it's pretty clear when I'm talking about life expectancy that I'm going to be talking about years. And I could put something in here into the subtitle if I really wanted to. I could say years in 2007. I think it's not absolutely necessary. So for me, this is a much better chart than what we started off with. Even though, there's a good argument to say that you could add in more things, right? But it's kind of what we're trying to do here. Is we're trying to take the data and build up just what's necessary, and then add on things that make it more aesthetically pleasing, and then that's it. That's when you need to know to stop. Okay, so on color, right? So something we talked a little bit earlier on about when we looked at that tweet plot. Color can be misleading too, right? So there's something about this plot where I have changed the colors that I really don't think is good, right? So think about what that might be. If we look at the earlier one, we have these kind of we have these kind of blandish colors, will we say? These earlier ones are, well, they're how should I put it? You're right. They're vivid in a sense, but they're not highlighted colors, right? So the red is not like stark red. The blue is not stark blue, right? And the reason for that is because if you have these kind of categorical data sets, you don't want to give the idea that one is being highlighted and one stands out from the other, but also you want a clear contrast to show that it's kind of intuitively that these are categories, right? Whereas over here you have this this situation where, to me at least, it reads like the color means something, like it represents something, like Oceania should be like higher than in some way, and it scales down. When that's not what I'm trying to convey, right? So that's an important thing with color. The key thing is with color, you want for categorical variables, you want distinct colors, but you don't want anything to stand out too much. However, if the data has some kind of an ordering on it, then you can use colors from the same palette. So say blues, that kind of move in a way that's intuitive with the data. Okay. So I just highlighted that. So you want to use distinct colors that don't stand out for categories, and don't use scaled colors for categories. Okay. Let me see here. Now, what about this? So this is another way we could represent that same data. We, instead of using bar charts, there's no particular reason we have to, we could use something like this called a bubble chart. There's something kind of wrong about this, and I would love if someone would chime in and tell me what it is. There's something very misleading about this chart. Any ideas? Want to type in? So
I think one can be like if they ignore the numbers and only look into the circles, what they will think. Like for example, if
yeah.
you look into the circle of Africa without seeing the number, what
Mhm.
life expectancy you will expect.
Yeah, exactly. So like, yeah, you look at this and you think Africans have got a very, very low life expectancy compared to other continents. And like, it's not entirely true. So the reason is that the axis here doesn't start at 0. And so a better way of looking at this would be to either, generally speaking, the axis should just not start should just start at 0 for data like this. However, at the very least, if you're going to do something like this, you need to use a different metric. So you need to say, look at things in terms of percentages of different things. Let me show you how we can fix this. Right? So it's very simple. All we need to do is bring the thing back to 0. And then you see that, yes, okay, it's true that there's a disparate, they're disparate, there's a difference in life expectancy, but it's not enormous, right? Yeah, so that's the thing, is back here, we started at 50, and you get this kind of arguably misleading thing. I think it's here, and again, it is a question of taste in the sense that, you could argue that this plot shows that there is a huge difference in life expectancy. That's very meaningful. Like, we're talking about life expectancy 55 versus 81. Like, that is a meaningful difference. However, I still think it's a little bit it's a little bit misleading all the same. Okay, so where these bubble charts really come in handy is when you have like a whole bunch of different categories you want to do at once. So here I've expanded it out, where I'm not just looking at the continent, I'm also looking at like a whole bunch of different countries. And you see on the left, you just have a lot of, it's a bit heavy, right? There's just a lot of ink there, I guess. And the plot and the dots, I think, help. And here, of course, you can use color to still encode that continent information, which is nice. Okay. Let me see. Okay. Now, the next thing that kind of follows on from this is, there's other parts of this data we'd like to show. So in the first set, I just showed you the average for the continents, but I actually have a whole bunch more data. I have a whole bunch of information on the different the different countries, right? So here, what I've shown is this is a density plot. Okay, so what this shows is when you take all of the different observations for the countries, it shows you what the life expectancy is for that country. I guess what I mean by that is it's showing you here that if you look at all the countries in the world, there's a big chunk of countries that have life expectancy somewhere around 70. And then there's another chunk that's more around, I would say, 50. Right? But that's kind of, it's showing you the distribution of life expectancies across the world. Okay? And this is, I think, it's certainly better than just that single number for each of the continents, because it shows you all the different variation. Right? Something you can also do with a density plot like this is you can split it up into different groups. Okay, so so in this plot, what I've done is I've split it up so that the color represents the continent. Okay, and what that can now tell you, what we couldn't really tell before, is that, okay, yes, we see Africa here is lower, right? But at the same time, if you follow it the whole way through, you actually see that some countries in Africa are actually way up, and their values are high in as high as like Europe or the Americas. Right? Similarly, you see that the values for Asian countries go all the way from the lowest to the highest. Right? So you can just about follow that kind of light green there. You follow that line, you see that they really have a huge spread. Okay, now you do see that Europe and the Americas tend to have they're more tightly around the top end of the spectrum. So yeah, this is a good way to represent variation. It's called a density plot. One critique I would say about this is there's a lot of overplotting here, meaning that like there's just a lot of things on top of each other, and it can be a little bit difficult to tell what exactly is happening here. Okay. Does anyone have any questions so far? Any of the plots they maybe didn't understand or they wanted to know more about specifically? Just let me know. Okay. Okay. So here's another way to represent variation. Okay. So this is called a box plot. Okay, a box plot is very common in statistics. It's kind of a traditional plot in a lot of ways, but it's a little bit trickier to explain, I would say, to a general audience, but it has a lot of advantages here, right? So what's happening here is each box plot has these kind of 5 points marked into it, okay? So the thick black line in each of these boxes is the median of the data, right? So what's the median life expectancy in Africa, in the Americas, and so on, right? And then the box covers what's called the interquartile range. It covers from the 25th percentile to the 75th percentile, right? And then the lines usually cover something like the 95% of the data. And then after that, you have dots that represent outliers, okay? So what this kind of tells you is that, you know, for instance, in Asia, you could say that most of the data is going to lie between, or I suppose half the data is going to lie inside the box. Almost all the data lies where the lines are, and there's no outliers there, right? Whereas Europe is interesting. Most of the data is in quite a tight boundary, whereas with a few outliers at the end, okay? So there's two criticisms I would make of this particular plot. First of all, is that there's no y-axis, which means that I can't actually tell you, for instance, off this plot, I just can't tell you what the median is in Africa, which is not great. And the other thing that can happen very easily with a plot like this, which is a bit more subtle, is that they can kind of be badly weighted, right? So I'm going to show you how I fix this first, okay? So yeah, so that's just the axis is missing, which is a big no, okay? Here I've changed it a little bit where I put the axes back in, or the numbers back in so I can read them off. But another big thing I've done is I've weighted the different countries' observations by population, right? And the reason why that was important is because when I really think about it, when I'm looking at all the countries in Asia and I want to try and talk about life expectancy, it in a lot of ways would make more sense to talk about you know, the life expectancy for per head of population, rather than trying to give it just for the particular country and weighting the countries equally, right? So this one is a little bit different, and you can see how the data changes here, and it shows that, like, okay, so Africa has gone down quite a bit, and the reason is that even though there's quite a few countries in Africa with relatively high life expectancies, the population, the countries with the most population tend to have lower life expectancy. Okay, so yeah, so that's a good choice. A box plot encodes an awful lot of information, which is nice. But again, it's for a technical audience. Okay, we added back in the y-axis. Okay, so the next thing I thought would be nice to look at would be how do we represent change in graphs and in plots. So another aspect of this data set that I have is that I also have the population for all of these different countries and continents, etc., going back to the last 50 years. And so I thought, well, okay, I'd like to show how the population has changed and what might be a good way to do that. Okay, so the first attempt here is where I just do the basic thing of taking the population, plotting it in a line chart, or it's a standard chart like this, and seeing what comes out. Right? And what you can see is that it's not very good. So maybe take a minute to think about what specifically is wrong with this plot. Any ideas? So if we look at the y-axis, right, we see that we have this scientific notation because the numbers are so big, right? We're moving into the billions, right? Exactly. It's very, very hard to interpret this data, right? Because there's a couple of things, right? First of all, there's a real big difference in scaling between these groups, right? So Asia just has like a much larger population than the other continents. You know, Oceania, we really can't tell what's happening because of that. And so, yeah, those are some of the biggest problems, is that you really can't tell. I can't tell you what's happening in Oceania because the numbers are too small. I also can't tell you specifically, you know, what is the population of Asia now. Like, it would be hard to interpret. I'm just going to go back one because Mariam has a question here on the box plots that I think is important. So let's see here. Right. So yeah, you're exactly right. The little vertical lines there, they usually represent the 95%. 95% of the data will be between the vertical lines, right? So that, like, the horizontal box holds about 50% of the data inside it, and then the vertical lines usually would go from the 2.5 percentile to the 97.5 percentile, right? And then anything that's outside of that will usually be represented as a dot, and it's considered an outlier. This is also great for data. This is a really good way for data, for modeling and things like that, because it kind of builds in this idea of detecting outliers in your data, which is important for a lot of uses. Okay. So back to this, right? So anyway, we're going to make some improvements. So this is another way I can plot this. This is known as an area chart, right? And it has a lot of advantages over the other way of doing this for a plot like this. The big one is, you know, it was able to show both the growth for each of the continents, for the most part, and it can also still show you the absolute values, which helps with perspective. It gives you a sense that, okay, you know, the population in Africa has grown, but it's still minute almost if you compare it to the population in Asia. The other thing that's happening here is the scale is much better on the y-axis, right? So it's in millions. Arguably, I maybe should have put billions. And actually, I think if I did this again, I would have put billions. But either way, now we can kind of look at the plot and say, we can follow over, like, the population in Asia right now is something just less than 4 billion, which you couldn't really do with the earlier plot. It still has some problems. One of them is that we haven't really dealt with this issue of Oceania, where the population is just so small that it's kind of, it's just not, it doesn't compare well with these other groups. So you can't perceive any difference. It might be that there is no difference, or it might be that actually there is a difference, but we're not perceiving it. So another way of doing that is to do something like this, right? So this plot starts off with the value that we had in the beginning of the data. So the value for each of the continents in 1952, and then it compares that value. It's what's the percentage increase over that value at all the different points, right? And so this just has a lot of advantages in that it really tells you something about the way the rates of change, the way these things have changed over time. On the other hand, it doesn't show you anything about the relative kind of importance of that change. Okay, so here you can see pretty clearly that Africa has kind of had the strongest growth. The Americas and Asia have kind of similar value. Europe seems to be slowing down this growth pattern quite a lot, right? And Oceania, you can see there actually has been quite significant growth. Okay, so let's see where we'll go next. So a natural way of mapping, of looking at this data will be to put it on a map, and that's completely doable. You could put this in something called, I think it's called a chloropleth. The point here is that you take each of the countries and you basically color them in on some kind of scale that represents the data. And what's great about this is it really is good for kind of data that you expect some kind of regional relationship in. So here you can see that like the European countries kind of have similar values. The sub-Saharan African countries have relatively similar values. There is, again, one problem that happened to me when I made this plot that happened completely by accident, which you should be careful of with things like this, is there's actually missing values here, okay? And so one of the things that's very misleading here is that these gray, like the Russia being gray, is not gray because it's like got a value between 50 or 60 or something like that. It's just gray because I didn't have data for it. So anyway, I've moved in this next plot, I've changed the scaling to try and represent that a bit better. It's still not perfect because the gray is kind of maybe a little bit on that spectrum, but for now I'm gonna call it a day. But yeah, so you should always think about, is there a possibility that some of these values are misleading and just by accident by the colors, okay? So here is just a different scale I've used. And again, you see kind of the regional variation. You can see kind of better variation here in the Americas, how kind of North America has a little bit higher than Southern America, South America, and so on. Okay. The next thing you might ask is, okay, can we combine these two ideas? So how can we combine looking at this graphical data, this map data, with the time element? And a great way of doing that, in my opinion, is to use a GIF, okay? So this is something I put together where effectively I take those map plots and all I do is I just kind of play them over on top of each other for the different values that I have. And you really get a sense of how it changes, I think. I think it's pretty good. So what I love about this is you can see that for the most part, it's getting better in basically all countries, right? It's not that, even though like even in 2007, Africa in general or sub-Saharan Africa had lower values, it is still definitely improving for where it was in the 1950s. So that's good. So I think there's just a lot of information here, and it's also very intuitive that people can understand. On the other hand, you should always be careful about, GIFs. First of all, they're not very shareable, and so obviously you can't print them in a book. And second of all, sometimes it can be fun to make something like this, but it actually can obscure the data more than it helps. So just be aware of that. Okay. So I'm going to move on to one more little topic that I think is important when we're trying to plot things out. And that's, how do we plot correlations, right? Connections between two different groups. Right? So you're going to do this all the time. If you're doing any kind of data work, you're going to try and figure out, just by looking at it, if there's a connection between data. And so here's one little example that I just threw together. So this is a quick plot I did, where all I do is I plot the life expectancy against the GDP per capita. Because I might suspect that there's some relationship there. And this is for the year 1952. Now, here, I really can't tell if there's a relationship. It's very, very difficult. There's a big outlier over some European country over here that has kind of ruined my plot in a way. But also, it's, when I really think about my data, it's unlikely that GDP follows this kind of linear trend, and something more exponential might be better, right? So to fix this, I can change the scale of my plot, right? So instead of having the x-axis follow kind of just a linear scale, we can actually scale it up in an exponential way, right? So here I'm using log 10, and it shows much better kind of what's happening, right? There's another variable that's mapped here, which I haven't written, which I should have, which is that the size of the dots is actually the population of the different countries. But anyway, that really should be there. But again, it just goes to show, every time you look at a plot, I think you can find another issue with it. So there's one more thing that's important that when you do a plot like this is that even if you use log scales on the axes, the label on the axis should just reflect whatever the numbers say, right? So here I've written on the tick points to be 1, 10, and 100, even though they're each just one apart. Because I've done that, I don't go and say this is the log of the GDP per capita, because it's not. It's if you follow these lines properly, you get to the right place. Okay. So now another thing we could look at here, arguably this is a little bit, it's good for showing the overall relationship. You really see this kind of linear trend between, well, exponential trend, I guess, when you think about the data, between life expectancy and GDP per capita. But what might be nice would be to see how this plays out in the different continents themselves. And so here we can do that using facets, right? Facets are a way of splitting your data up into little mini charts, and it often helps, right? So you can see, first of all, we don't actually have that many observations in Oceania, so that kind of explains a lot of why Oceania was kind of an outlier in some ways in this study. And you can see that the relationship is very, very strong in Europe and seen pretty strong in America. In Africa, it's kind of all over the place. And so a lot of the dots are, I wouldn't say that the relationship between GDP and life expectancy is entirely clear if you're just keeping it to the African countries. Asia, it seems a bit more clear, right? That's an interesting thing to look at, right? And now the last plot I want to show you is a way of just combining the whole lot together, okay? And this kind of builds up to a pretty famous plot that's seen. This is a Gapminder plot. It shows how for each of these different countries, weighted by population, how life expectancy has changed over the last 50 years. I think it's a really, really cool plot. This is not, by the way, to be clarified, this is not some plot that I've made. Even though I made this particular example, but the idea is a pretty famous plot that you can look up called the Gapminder plot. But I think it does a great job. It really shows the way that the countries have developed in terms of life expectancy. You can see, if you look at Asia, you kind of see this big jumping blob, which one of those blobs is going to be India and the other is going to be China, but you kind of see how like they've driven the increase in life expectancy there. You can see kind of the way some countries pop up and down. It's kind of interesting, worth digging into, I think. So the question I was kind of thinking was, what variables are represented here when you look at this plot? Right? So obviously we have life expectancy, we have GDP, we have continent, population, year, all of these things in this one plot. And that's why it's pretty impressive, and that like you can just get an awful lot of information out of this plot. The data to ink ratio is really, really good. But yeah, so that's the last plot I wanted to show you guys. And maybe now would be a good time to, if you want to ask some questions, if you want some tips, if you have particular plots you kind of are interested in, or even a data set, just let me know. So I'm going to send out an email to you guys later on with some information. All of the plots I've made here today were using ggplot in R, and I have a link to a free book that you can use to try and learn that. There's also a great book that I've been looking at that kind of talks about the art of data visualization. It doesn't use a particular language, and the reason for that is because these things change. So if you use a particular programming language, it might be out of date very quickly. So this just talks about the theory of how do you get information into plots, and how do you convey that to an audience. And then finally, there's a great Reddit called Data is Beautiful that people post their visualizations to. I think it's really good. It's great to see kind of what other people are at. And there's a whole school of different visualizations out there that are really worth looking at and worth thinking about. So yeah, so I hope that's been somewhat helpful. Any questions? Interesting. Are there any, so Zayed asks, are there any rules when it comes to choosing colors other than the use of color scales? I would say there's yes is the quick answer. One big thing you should think about is color blindness. And it's kind of a thing of like, if you're not colorblind, you don't think about it for the most part. But a lot of libraries will have built-in scales that have been tested and are appropriate for color blindness, right? So certain plots, if you have plots that have a lot of green and blue in them, often that would be confused if you have color blindness, and therefore, yeah, so you should change that. Yeah, that's one thing. Let me think. There's other questions of color. There's also, I would say that, like, you know, some colors have certain emotions attached to them. So if you have a lot of red, it often suggests kind of anger and passion and these kind of things. And so you should take that into account. But for the most part, I would say use standard scales that are built into whatever software you're using, rather than picking your own colors. But also, you know, usually there'll be good documentation on those scales, and you can say, you can tell what they mean specifically. Yeah, in that documentation, there'll be something about, you know, is it appropriate for color blindness, and what would be the best uses for it, I would say. Yeah. Any other questions, guys? No. Okay. Yes, absolutely. So I did go in specifically to like thinking about different data types and then taking a visualization from there. And the reason is because I think people can get a little bit too hung up on it. But, you know, I would say that we all make certain intuitive kind of judgments based on on types of plots that we're looking at. So, for instance, in a line plot where we have lines, you'll intuitively assume that has something to do with time, because it's such a common plot for things against time. And so be very careful about using something that's not time with a line plot. I think that's maybe not so good. A scatter plot, which you have just the dots, doesn't have that problem. You know, you should think about your data in terms of you should think about your data in terms of if your data is categorical, ordinal, or continuous as well, because that can affect a lot how you're going to plot it out. In particular, when you're thinking about color and you're thinking about things like that, you should take that into account. The color thing is that we're talking about earlier on, where you have kind of continuous scales of color versus like distinct scales of color. The ordinal issue is more about like how you order the things on the page. Naturally enough, you know, if you have data that's like from very bad to very good, it should be done in that order. Okay. Mariam, yes, sure, yeah, that would be good. Why not? That would be cool. If you're willing to, if you're happy to share that with everybody in the group, we can take a look. It would be interesting.
Hi, Daniel. Thank you so much. I just would like to show you one plot of mine, and just to take your opinion in that.
Yeah, for sure.
Like when you look at it, what would you say at the first sight?
Yeah.
Yeah. So I'm just. I'm not able to share my screen. I will.
Oh, I'll stop mine. Hang on, let me see. I think that's probably why.
Yes.
Okay, let's see here. Right. You have a tough job here. I've seen plots like this before.
Yeah, a lot of pages are open. Sorry about that, but
No, I know, I understand. Are you like is it like biostatistics or something like that?
yes, exactly. So
Yep.
the x-axis is basically plates, and I have certain controls that I needed to count in each plate. And I was asked to do a plot for that, but I wasn't sure whether this plot is good representation of the data or not. Although, like for example, if that would go for a publication or something, is it good to show that, or you mean, or I mean, if it's possible?
Yeah, well, let's talk about it, because this is it's interesting. The thing about it is, you know, one reason why like this plot is tricky for the rest of us is just because we're not in your field. So that's like one reason why it's always going to be tricky. But I think, can you tell me what the y-axis is here? So the 0, 1, 2, 3, 4, 5.
The counts. So these are the counts. And then in the legends, we have the controls. And then I'm counting in each plate how many of these controls I have.
Right.
And that's basically just to do a check whether I have false positives and false negatives in my data. So, yeah.
Yeah, so this is tricky because there's so much data. One thing I'm thinking straight away would be, you know, you could have a bar chart, right? Where the bars have, you have kind of bars which are beside each other, I guess. And that might help a little bit, okay? So then for each of these plates, let me see, would that help? Yeah, so like each plate would then have like 6 bars. Now that's going to be an awful lot of data.
Yeah, exactly, because I tried the bars as well. And,
yeah, worse. Okay, let me try and see. Yeah. So, but the idea, I guess, the point you're getting at here is you want to find outlier things, right? That's what you want to do. Right.
Yeah.
So actually, yeah. Well, that's actually, this is actually right. So this plot actually is not that, it's pretty good in that sense. In that, you really just want to see these things that are marked 1, like these 5 points in the middle, right? Those are the things that are kind of interesting. Or yeah,
no, all of them actually, not just these points in the middle. All of them are interesting because also I'm not just looking at the outliers. I'm looking also at the false positives and false negatives, and that plot gives me the idea correctly. But I was just wondering whether like having these overlaid points, like there are points over each other on the top of each other. So is that fine or not, or is there a better way of plotting this data? I mean,
yeah, I'll be honest, I don't like the overlaying for sure. One way I would think that might be, one thing you could do is, instead of having them overlaid, you know, they don't actually, because this is, how should I put it? This is ordinal data, right? None of these values are ever going to be like 0.5, right? So what you could do instead would be, for each of these dots, kind of stack them up. Let me see if I can explain this. So say like in this first example, 1, 2, 0, 5, 2, right? You have like, I guess there's like, maybe say there's OTP and untransfected in there.
Yeah.
Whatever.
Yeah.
What you would do is you would plot to have the OTP on the bottom, and then just kind of stacked on top of that, you'd have the symbol for untransfected, and on top of that, whatever else, right?
Yeah.
Similarly, you could do something similar for the 5, where you would just have, and that way you could see all of the symbols, and they would just be gathered around the 5 rather than necessarily on it, you know. Now, technically, how to do that, I'm not sure off the top of my head. Do you see what I'm trying to suggest, or does that make sense?
Yeah.
I think that would help, because then you would like, you would be able to read all of the data pretty straight away, because like right now you couldn't really tell, say, if Like there might be a symbol that might be in 0 and it might be in 5, and you just wouldn't really be able to know. So
yeah, but by looking at this plot, do you think it's self-explanatory, or you would, for example, as a reader, think that, oh, I need a legend or sorry, a caption for that plot to understand it?
Yes, I would. I mean, yeah. I mean, I think one thing about, like, especially for scientific graphics, long captions are perfectly fine, right at the bottom. Like you put a long caption. Like, you know, some people think that you should just put a couple of words. I think no, you should write out. It's perfectly fine to write a paragraph on what this is if that's what it needs. You know, I would definitely put a title. I'd put and I'd put like a label for the y-axis and the x-axis. Even though, you know, I mean, yeah, to me the y-axis label is important. It's not clear why. It's not going to be clear what these numbers represent. Another thing that, you know, another thing to consider would be, you know, I'm thinking if there might be a way to kind of split up these, you know, I'm thinking about whether it would be helpful to have kind of horizontal lines, basically, to try and split up these groups. I don't think so. The more I think about it, I think you don't need that. But yeah, I think that it would definitely benefit from not having the points plot over each other in some way. Often, like, if you look up a thing called jittering, I guess you're using like matplotlib or something like that.
Yeah.
Right. I'm not great with matplotlib, but definitely I'm sure if you look up like jitter points in matplotlib, it will do what you're talking about. And then let me see, what else can we kind of, definitely needs a title, definitely needs probably needs a y-axis label, I think. And I think that would definitely help.
Thank you so much.
Yeah, no problem.
Thank you.
Okay, so I will send you guys an email with the slides. I'll also send you on the code that I use to make the plots, and the data is publicly available anyway. And it's in ggplot2, which is an important plotting library that is used a lot. It's in R, so if you use R, that's great. If you don't, it's still going to be kind of, I think, you know, a lot of the principles of the code are very similar in other languages too. But yeah, I think I debated whether I would show you much code today. I decided not to, simply because you know, code changes. It's just a tool at the end of the day. The important part is more thinking about how to improve plots that you have. Okay. So feel free, if you have any interesting plots or things you want help with, just shoot me an email. I'm always interested. So yeah.
Thank you, Dan, and thank you guys for attending. So as Dan mentioned, he will send you the slides, and he also will send you the recording after receiving it from me. I wish you nice Sunday, the left few hours. It depends also what time is it in your country.
Yes. I have the whole day, so. Okay. All right.
So thank you, and good luck.
Bye-bye.
Bye.